Hey, good afternoon, everyone. My name is Niranjan, or Niro. I'm the Central AI Product Manager for Siemens EDA, and I'm really excited to be here in San Jose today at NVIDIA GTC, and it's day 2. And today I have two technical leaders with me from Siemens and NVIDIA in Juan and Prakhar. I would love if you could introduce yourself, Juan, Prakhar. Juan, you want to go first?
Sure, my name is Juan Rey. I am the General Manager for Caliber in Siemens EDA, as well as the CTO for the Siemens EDA division.
My name is Prakhar Mathur. I am EDA Developer Relations Lead. I work with the EDA industry to help all the tools accelerate on NVIDIA GPUs and use the latest AI and the technology that we're putting in the GPU to be leveraged for EDA.
Oh, nice. And I'm excited because today's topic is basically about three things. It's about understanding why GPU acceleration is probably the need of the hour in CAE, or computer-aided engineering and chip design. And second thing we will dive into is how is Siemens and NVIDIA approaching this problem and working together as well as individually. And third is we'll try to show some proof points and examples and customer value to see where this is all leading. So first I want to start with Prakhar, you've been in the industry for almost 25 years, also with NVIDIA for 25 years. So why do you think now is this high time of having, it's actually an absolute necessity for GPU acceleration in chip design and CAE. Also, if you could come a bit closer to the mic, that would be great.
Of course. Yeah, so what we've been seeing in the chip design world, the need of compute is going up every single year. Just to take an example, about less than 10 years ago, we had the top-end chips, about 20 billion transistors, like NVIDIA Volta chip at 20 billion transistors. And today's latest chip, Rubin, has more than 300 billion transistors. That is just a number, but again, on top of it, there's additional complexity as we go into deep sub-nanometer world. It's harder to converge, the costs are going up, the design cycles are getting longer. So to be able to just keep up with and keep creating the new technologies and to solve the new challenges which come with the new deep submicron devices, we need computational depth and computational resources which only GPUs provide today.
No, I think that makes sense. And since you mentioned this, how is NVIDIA's approach to solving this challenge? Is it something from an algorithmic point of view? I'm pretty sure there's also some memory issues that you have to take care of. So if you could point out 2-3 things, and then we'll get into one as well.
Of course. So there are multiple different ways. Of course, these are one of the most challenging problems in the world. And as Jensen says it, if anybody could do it, we'd let them do it. The problem is so difficult that we need to be involved and we need to be helping out the industry to find a solution. Memory bottleneck, as Niro mentioned, is clearly a problem, and tightly coupled NVLink with the CPU, GPU, higher bandwidth helps a lot in this parallelism that GPU provides. And the throughput that we can achieve with GPUs, that's really necessary to build the next generation EDA tools. And that's just to support the designs of today. Even today, the design cycles keep stretching out, and we need to be able to reduce that to produce more chips.
No, I think that makes sense. Like, these are important problems, and one of the things, since you mentioned, is Jensen loves to talk about extreme co-design, where NVIDIA and its partners, in this case Siemens, we try to work together, not just product to product, but even at an R&D level to make these advancements happen. So one, I was wondering if you could, in short, describe how is Siemens and NVIDIA at a high level working together to address GPU acceleration.
Sure, absolutely. We are extremely grateful for the possibility to cooperate so closely with NVIDIA, because the effort requires work in multiple different angles. The first one is on complete rewrite of algorithms. Many times the algorithms are ultra optimized for CPU type of architectures, and obviously GPUs are different. And so a complete rewrite is often needed for the most difficult problems. The second part is essentially the major approach that NVIDIA took to create CUDA-X and a series of libraries that are certified, validated, and that we can rely on and cooperate at that level to understand very well about how these libraries operate, how they are optimized, how they can be utilized. The next area, the third area, is essentially NVLink and the ability to actually exploit parallelism at the GPU level for multiple GPUs. And the fourth area is completely related to the complete re-architecting that they have done by GPUs with HBMs versus CPUs with going through a PCIe link. In each one of these areas, the close cooperation with NVIDIA to exploit those architectural new characteristics and hardware characteristics has been important.
No, I think those buckets make sense. Like memories also, sometimes people forget, but it's important. And talking about this, one, you're also the general manager for Calibre. And how is Calibre and the broader domain of physical verification going through this change of GPU acceleration, or how are they embracing it? Maybe you can mention a few proof points. How you mentioned that NVIDIA's engineers and Siemens engineers are working together. So if you could describe some of that, that would be great.
Sure, absolutely. The first one will be on rewriting of algorithms. When you look at it, it is impossible to tackle absolutely everything and rewrite everything from scratch. So the point is to start working on those areas where the problems may be tough but absolutely necessary because they are very time consuming, and one of them is PERC, the electrical reliability checks that are done with Calibre. In that case, there is a complete rewrite of these algorithms to exploit parallelism of the GPUs in the extraction simulation loop, and the accomplishment has been tremendous. A 15x proof point already observed in that area. Then when looking at GPU, HBM management of data transfer and so on, that is absolutely essential when processing the huge databases that you have in the physical verification stage with GDS2 and OASIS. GPU, HBM communication is absolutely essential to increase parallelism, reduce runtimes. And the third one, this is also working closely with NVIDIA, is the certification in cloud, mainly through Dell and AWS, that then once you have these systems, the IT departments do not have to actually deal that much with it because they are already deployed in cloud, has been certified and works. So all those areas are very clear proof points that we can accept.
No, I think that's powerful. Just to recount, 15x acceleration in extraction workflows, which are pretty complicated, is commendable, and I'm sure it'll just keep growing. Since one was mentioning Calibre, I was also reading recently about Calibre's OPC solutions, which are more on computational lithography. And one of the things that was interesting to me was seeing how Calibre OPC is leveraging some or multiple CUDA-X libraries. So Prakhar, I wanted to ask is, could you explain how CUDA-X and all the libraries are central to GPU acceleration? And then maybe we can take computational lithography as an example to explore it.
Of course. So CUDA-X library is a set of about 400 plus libraries which serve many different kinds of workloads, not just EDA-centric workloads. But there are some libraries which are specially designed for EDA, like cuLitho is one of them. And also there are some libraries which are very applicable to the problem set that we have, the way we solve the problems. Like cuDSS is one of the top libraries we use, we find useful in a lot of the electrical solution space. And with cuLitho, which is purpose-built for an OPC and ILT situation, we're already seeing a huge performance through our partners, and it's delivering the value. And the one thing which it helps the partners not worry about is as we go from one generation to the other generation, you get the gains from the GPU via the libraries. The libraries are already tested, they're verified, they work, and then all you have to do is go and upgrade to the next library, and you get the performance boost with the latest and greatest NVIDIA hardware. And similarly with cuDSS, when we are running a SPICE simulation, you get the exact same benefits, but on a very different kind of problem that you're trying to solve.
No, I think that's very interesting. I think I think we have been, Siemens EDA and Caliber have been using Coolitho, and I think the numbers I've been seeing is like 50x, 20x to 50x acceleration on OPC type workloads. Would you like to comment on that, Ram?
Absolutely. It has been one of the areas of great collaboration. Coolitho is absolutely essential for a lot of the development that we do. And you are correct, computational lithography is one of the areas that benefits, but I will actually mention that it can go even beyond that. In EDA, this team has been expanded and doing some extra development that expands beyond the standard computational lithography area.
Yeah, since you mentioned beyond it, so maybe let's change the gears a bit. I think another important area in EDA workflow that's very compute intensive is custom IC design and verification, where we have to run a bunch of SPICE simulations. And so I've been seeing some work with the Solido team that you mentioned and NVIDIA on making SPICE simulations a bit more faster. So would either of you like to comment?
Absolutely, I would like to comment if you don't mind.
Please go.
Yes, the Solido team, as you said, has also been working very closely on GPUs, and they have achieved a 5x acceleration in Solido SPICE, and that is on top of a 100x acceleration for variability analysis type of work. So these results are very impressive, very encouraging, because they are very much along the lines of what our customer base needs.
Yeah. And I think, Prakhar, to your point, right, you were mentioning this. I really like this aspect of extreme co-design, where I was talking to some of the Solido engineers, and their R&D have meetings with your R&D. And I think the broader aspect is, as the solutions get better, not only for Siemens and NVIDIA, but it's also benefiting the broader industry. So the whole sort of paradigm is shifting, ahead.
Yeah, we are not helping Siemens build NVIDIA-only solutions. We are helping the whole ecosystem. And this is where getting the experts from a different field, like my background at NVIDIA has been designing chips and not really creating software, whereas Juan's background is software. Right? He's an expert and master at that. And then when we put different kind of expertise in the same room and we discuss, and that's where we solve the real issues, which are not domain specific, but these are cross-domain specific. We bring in the user point of view, and you build the developer point of view, and then we get the best and most optimal solution on GPU, which helps the end customer, which is the chip designer in this case.
No, that's great. I think looking ahead, since you mentioned the broader industry, Prakhar, is one of the other areas that has come up in the last few years is 3D IC. Very complicated, especially in the last, few months, given the memory industry, it's been even more important. And it's not only because it's not pure chip design or electronic simulation. You have to have thermals, you have to have stress. So where do you see opportunities there in 3D IC exploration with GPUs?
It's more than an opportunity, it's a necessity. For when you put different chiplets together, when you stack chiplets, you uncover problems which are not just electrical issues. These are not just sending a current across a wire issue. Now you are looking at thermal warping, you are looking at yield, you are looking at package issues, you are looking at structural weaknesses in the package. And everything now, you think about it, these are some of the most expensive pieces of design. So you got to do it reliably, and you have to do it over thousands and hundreds and thousands of time. So being able to run these in simulation before you actually go do it is really powerful. It saves your design cycle, it gets you to production faster, and it is a better solution.
Yeah, that makes sense. One, you lead 3D IC efforts, and I think run the central team that works on 3D IC. Where do you see potential in terms of GPU acceleration, especially because Siemens also has Flowtherm and SimCenter, the broader portfolio?
Absolutely. We have been working for many years now on thermal problems, stress-related problems, very closely integrating the tools that come from the rest of Siemens, the simulation teams, as you said, Flowtherm, and now Altair with the newest acquisition. Both areas are very much in the line of doing GPU acceleration and achieving great results. So we are looking into all that area because on the thermal side, from one side, we work with these multi-scale type of problems, but when you go to the final verification areas, you really need to go through the acceleration of finite element analysis methods. And those areas are very much prone to be well accelerated with this cooperation with NVIDIA. On the stress analysis side, you also have the need for doing finite element acceleration of these systems, and both teams are working very closely together. And the last area is when you do electromagnetic analysis, especially at the package level, to understand interference and different type of problems that create serious issues when you integrate all these multiple chiplets. The great thing for us in Siemens, in the digital industries software area of Siemens, is that we have all these teams working very closely together to tackle 3D problems, and they all understand the need for GPU acceleration.
No, I think that's great. Like, just to summarize, it seems like we have all the pieces coming together in terms of 3D-IC, and then because they are multi-domain, we are also working and leveraging bunch of different CUDA-X libraries to make them GPU enabled. I know we are getting close to time. One of the things that I wanted to lastly point out is, I think we talked about what great benefits that we are seeing: 15x, 20x, 50x accelerations, some future-looking things that we are working. Where do you see are the challenges in achieving these benefits going forward, like looking the next few years, if you will?
So looking forward, next few years, of course, one of the straightforward problems, or one of the problems, as one mentioned, which are more applicable to GPUs, we are already on our way to solve those using GPUs and accelerate. But there are some problem sets which are traditionally been designed and solved using linear approach, sequential approach. We have to rethink, we have to have our engineers trained to rethink in a problem, reformulate the problem so you can solve it in a parallel way. If you keep solving it in a linear fashion, you're not going to get the speed up. So that's one of the biggest problems that we have, and that's what we are finding some very unique solutions when we start looking at that. It's not that we can't find it, but each one of those tools which have been written over the last 30 years, and then we have to somebody has to put the work to reformulate the problem so they are adapted to GPUs and they can harness the power that GPUs provide to them.
Yeah. I think, where do you see the challenges in GPU acceleration? I think one of the things I was reading, and it's probably a more EDA industry-wide thing, is we just have less number of engineers that are working in EDA, and so we need to we need more human power and intellect to your point, Prakhar, to keep hammering at this to make it happen.
Yeah, absolutely. Rewriting of algorithms requires expertise and a different way of thinking. So from the educational programs all the way through the learning on the job and the learning with the most advanced systems is one of the areas where we are putting a lot of effort to actually solve and address the issue that was just mentioned. So definitely that area is absolutely fundamental. Another area that is very critical is that it is not possible to get all the areas parallelized at the same time.
Yeah.
So picking and choosing and selecting those that really makes the most sense really is a key area to put a lot of focus, because the obvious one is those areas that take the longest, but the other approach is also to look into flows, right? And understanding what are the tools that make sense to get combined, and then use that also as a critical guidance for the areas where to go.
I think that's an excellent point. One is prioritization of areas, because or buckets, because we have limited resources, limited time in all aspects. I think we're getting close to time. Prakhar, if you had one takeaway for the audience, what would that be?
We are going to accelerate all EDA tools on GPU. It's not a question if, it's just a matter of time, and we will see by the end of the year another handful of tools will be running and providing value to our end customers and speeding up the workflows. And every month after that, we will see more and more tools coming in.
One, do you want to give a takeaway from a Siemens point of view?
Yes, that the 10x acceleration and runtime reduction that our customers need for delivering the systems of the future, demands using GPUs, and so we are definitely putting a lot of effort. But one of the great things is that we have already very strong proof points, right? Already mentioned the 5x Solido Spice acceleration, the 15x PERC acceleration for the extraction simulation loop, the 20x acceleration on some critical areas of computational lithography. All that is coming together, and those are only the areas that have good proof points, right? Of course, we have many more things under work. Yeah.
No, I think that's great. Like those proof points really, show that this is of substance and real, and not just we're not just spinning our wheels. It was really fun chatting with both of you. Essentially, what I have learned is, GPU acceleration is need of the hour, especially in chip design, as the design is exploding in terms of complexity and workloads. It seems like NVIDIA's approach and Siemens' approach is working together very closely, trying to rewrite algorithms, trying to use CUDA-X, trying to have parallelization, also try to solve memory bandwidth issues, and so on. And I think I'm really excited to see what happens in the next 1-2 years on different EDA tools and broad CA tools. Thanks for joining me, and I wish both of you a great GTC.
Thank you so much.
Thank you very much.